A polonium-210 nucleus decays by alpha particle emission to lead nucleus. Complete the equation for the decay of polonium-210. So our polonium is going to decay to form, or it's going to undergo alpha decay. So it's going to give an alpha particle, which, as we said before in our table, is a helium nucleus. So we can represent that as such, right, where the atomic number is 2, our number of protons is 2, and the mass number is going to be 4. Let's put that in right here. Plus, we're going to form, it says we're going to form lead. So now, we can represent that now as lead Pb, right? The atomic number is going to reduce by 2, so we'll go down to 82, and the mass number reduces by 4, so we get 206. So that would be our expression, right? And we're going to get some amount of energy as well, right? And we could say plus energy, right? So that would be our equation there. So now, see what's next. So next thing now, it says that polonium-210 has a half-life of 138 days. At a certain time, a sample contains 6.4 times 10 to the 6 polonium nuclei. Calculate the number of polonium nuclei remaining after 522 days. So now, what we need to do now is we need to determine, okay, how many half-lives, right? How many half-lives? So we could say that number of half-lives that will be completed in the 552 days will be equal to the number of days, right? 52 days divided by 1 half-life, which is 138 days. So what we see now is that this now becomes 552 divided by 138, which we get 4. So we're going to have 4 half-lives taking place. So what we need to do now is to find out, okay, how many polonium nuclei would be present. So what we'll see now is that we're going to start out with, let's say, 6.4 times 10 to the 6. After 1 half-life, say after 1 half-life, it's going to go down to half of that, which is 3.2 times 10 to the 6. Then after 1 half-life, then after another half-life, it's going to go to half of that, which is 1.6 times 10 to the 6. Then after the 4th half-life now, it's going to reduce again to half of that, or reduce by half of that, which is 0.8 times 10 to the 6. So we could represent that as the number of polonium nuclei present would be, so let's say, therefore, number of nuclei present would be equal to 8 times 10 to the 5 nuclei, right? So after each half-life, so this is the first half-life, second half-life. Okay, so it's 4 half-lives. So first, second, this is the third. So therefore, now we're going to have to change this because we're going to consider 1 more half-life. So our after the 4th half-life, let us say I represent it here. So after the 4th half-life, it goes on by half of that, which is 0.4 times 10 to the 6. So therefore, number of polonium nuclei present there now is going to be 4 times 10 to the 5 nuclei. So this would be our final answer.